Today we're going to be examining the fundamental theorem of calculus, which is one of the foundations of integration and relates integrals to derivatives. Our objective for today I will use the fundamental theorem of calculus so that I can interpret the definite integral as a rate of change. For today's notes, you will need the undercover handout, which is available on Canvas if you didn't pick one up in class. So in today's scenario from Undercover, you have just taken over as manager of a struggling umbrella company. Umbrellas are manufactured at a rate given by G of T equals 20T minus T squared, umbrellas per hour, for 0 is less than or equal to T is less than or equal to 14. And T represents the hours after the factory opens in the morning, which is 6 a.m. The handout does have this graph, which shows the rate of production. So that's something to keep in mind. This is the rate of production. After a leisurely breakfast, you arrive at work at 9 a.m. Write an expression that gives the number of umbrellas that have been produced before you even arrived. So we're going to write an expression that gives the number of umbrellas that were produced before 9 a.m. So as a reminder, when we're talking about these types of rate functions, in order to find the number from the rate, we're going to look at the area underneath the curve. So we're going to look at the area from, well, if 0 is 6 a.m., so we're going to look at 0 to 3. So let's write an expression that gives the number of umbrellas. Well, I know that the integral is the sum of the rectangular approximation method, rectangles. So I'm going to write an integral. My lower limit is when the factory opened, so at 0. My upper limit is when I arrived at work, so at 3. And then I need to include the function. Well, the function was G of T equals 20T minus T squared. So 20T minus T squared. And then since my variable is T, it's going to be dt. Now we're going to approximate roughly how many umbrellas were produced during this time. I'm going to allow you to come up with your own number. Everyone's method of estimation is going to be different. So go on ahead and pause the video and come up with a number for how many umbrellas were produced during this time. Okay, my method of approximation, I'm going to be really simple. I'm going to do a trapezoidal sum of that, which would be 1/2 delta t, so 3, times y1 plus y2. y1 is 0, y2 is 50. So this would give me approximately 75 umbrellas. At 12:30 p.m., you break for a long lunch. Write an expression that gives the number of umbrellas that have been produced that day up until your lunch break. So we're going to have a new integral. It's going to be from 0 to 12:30. Well, 12:30, from 6 a.m. to 12:30 is 6.5. My accumulation function stays the same, 20t minus t squared dt. Roughly how many umbrellas were produced during this time? So once again, I'm going to leave the method of approximation up to you. You can use a rectangular approximation method. You can use an average. You can use a trapezoidal approximation method. The method is up to you. Go on ahead and pause the video while you come up with your approximation. Okay, I'm going to use a method revisiting my trapezoidal approximation. So I already had 75 from before. So now I'm going to approximate from t equals 3, which is when I arrived at work, to t equals 6.5. I'm going to do this with another trapezoid. So 1/2 times 3.5 times, now y1 is going to be 50 and y2 is about here, which looks to be about 88. And I get 241.5 for that, which when I add to my other 75 gives me 316.5. Part 3 says write an equation involving an integral for a function f of x that gives the number of umbrellas produced x hours after the factory has opened. So now we actually need to write an equation, f of x, that gives the number of umbrellas. So f of x equals an integral from 0 to, now notice they say x hours. So x is going to have to go up here. We don't know how many hours. Of 20t minus t squared dt. The reason we leave it in t is that we're still taking this as a rate of time. There is no time variable in the original function in terms of x. It's given to us in terms of t. X is the number of hours that we're accumulating. So that goes with our integral, not with our function inside, with the integrand and the variable of integration. Find f prime of 8 and interpret your answer in the context of this problem. Well, f of x equals my integral from 0 to x of 20t minus t squared dt. Well, in order to find f prime, I'm going to have to take the derivative with respect to x. Now, we've already somewhat talked about this when we started this unit, that the point of calculus was to analyze not just how quickly something changes, so derivatives, the instantaneous rate of change, but also the accumulation of that change over time. This naturally makes derivatives and integrals inverse functions of each other, inverse operations. So when I take a derivative of an integral, just like when I have sine and inverse sine, or addition and subtraction, they are going to undo each other. So the d dx is going to get rid of the integral, but it's going to do something very, very specific with this integral. This x in the top, which I'm sure you're going, why do we have an x instead of a t? Well, we're taking the derivative with respect to x, so that x is going to fall in or substitute in for t. When I take the derivative with respect to x, and x is in the integral, not in the integrand, but when it's the upper limit of my integral, x substitutes into my integrand. So now I'm going to have f prime of x equals 20x minus x squared, and the dx goes away, or the dt goes away. Great! Now I need to plug in 8. F prime of 8 equals 20 times 8 minus 8 squared. Which equals 96. Awesome. What does it mean? Take a moment, pause this video, and consider what this number means in the context of the problem. So let's go back and consider what f of x was supposed to be. F of x is the number of umbrellas produced. So f prime is the rate of change, or how quickly the number of umbrellas produced is increasing or decreasing at 8 hours. So I want you to put that into your own words. 96 umbrellas per hour are our units. So we are increasing at a rate of 96 umbrellas per hour at 8 hours. When is f of x changing the fastest? How do you know? So when is f of x changing the fastest? Well, it's going to be changing the fastest when the rate of change is the largest. The rate of change is our graph of G of t. So where does G of t have a maximum? It has a maximum at t equals 10.